Now see, in this question, a simple harmonic oscillation is represented by y is equal to 0.40 sine 440 t plus 0.61. You have to find amplitude, angular frequency, frequency of oscillation and initial phase. So, see here, this equation can be compared with this y is equal to a sine omega t plus phi naught. Here A is amplitude, omega is angular frequency, t is time, phi naught is initial phase. So, if we compare this equation with this, we find A is equal to the first one amplitude we can write A is equal to 0.40 meter. If it is in meter, so the amplitude is equal to 0.40 meter. Without solving you can get it. Similarly, you can get angular frequency. Omega is equal to 440 because omega is here, omega is here. So, this is your omega and here is 440. So, omega is equal to 440 radian per second. That is called angular frequency. Third one, we can get frequency from here. So, we know it 2 pi nu is equal to 440. So, nu is equal to 440 divided by 2 pi, that is 440 divide here into 2 into 22 into here 7. So, this will get cancelled here 70 hertz. So, the frequency is coming here 70 hertz. Now, see what is initial phase. So, in this equation phi naught is initial phase. So, obviously, this quantity is here representing initial phase. So, we can write here the fourth part, phi naught is equal to 0.61 radian, that is here initial phase. Now, see, a particle start oscillating from half the amplitude position. What is its initial phase? So, see here we know this equation y is equal to a sine omega t plus phi naught. This is the equation which is representing displacement of the body at any time t having simple harmonic motion, and at t is equal to 0 y is equal to a by t. So, we can write here a upon 2 is equal to a sine omega into 0 plus phi naught, this will get cancelled. So, half is equal to sine phi naught, that will be here phi naught is equal to 30 degree, that is equal to pi by 6 radian. So, this is the initial phase of the particle. Say a particle has simple harmonic motion of amplitude A. At what distance from the mean position is its kinetic energy equal to potential energy? You know, we know formula for kinetic energy is equal to half mv square, where v is equal to omega into under root of a square minus y square, where a is displacement, y is amplitude. So, we can write kinetic energy is equal to half m omega square into a square minus y square, and potential energy can be written half m omega square y square. Both are equal. So, we can write half m omega square y square is equal to half m omega square a square minus y square. This and this will get cancelled. So, y square is equal to here a square minus y square. So, twice of y square is equal to a square. So, y square is equal to a square upon 2. So, we can write y is equal to a upon under root 2. So, at the displacement of the a upon under root 2 from mean position, its kinetic energy will be equal to potential energy.